welcome to Assembly Audible. I'm your host, multimedia editor Jennifer Pierce. We're broadcasting from the Music City Center in the heart of downtown Nashville, Tennessee, and I am joined by Dave Deiwert, the president of Tracer Gas Technologies. Dave, welcome to Assembly Audible.
Thank you. It's good to see you and talk to you in person.
Absolutely. I appreciate your support over the years, and it's fantastic to interview you in person on the show.
Thank you. I look forward to being here.
Yes, absolutely. So tell me about your career background. I know you've been in the industry for
38 years.
Oh my goodness,
like
so
a long time.
What led you to start Tracer Gas Technologies?
Well, I've been doing leak detection and vacuum technologies for all this time, and what I enjoy the most in those fields is the training and consulting, helping people. And throughout my career, even when I was in sales, I developed the attitude that if you help people when they need help, business takes care of yourself. And I've developed a lot of relationships through the years that I'm seeing the value of that now that I've started my own business. So, leak detection training and consulting is a lot of fun, actually. I've seen so many different products and processes, things from shock absorbers to pacemakers to helping NASA with their vacuum processes. So it's been a very rewarding career so far.
So training is one of the services that you offer through your business, Tracer Gas Technologies. What does the training look like, and why do you think it's so important?
Well, when leak detection goes wrong, you're usually affecting quality and maybe health and safety in many products. So teaching people the correct way to apply leak detectors in the different applications is important for those reasons. My training courses, if they go the way I like them to go, I prefer to augment the lectures with demonstrations and then breakout sessions with hands-on training, because a lot of people, I think, are similar to me, that you learn more by doing. So if you have a leak detector set up in this application or that one, and the attendees can actually operate them, they seem to retain the information and enjoy the course more. Mm-hmm. You know, all lecture is very dry material.
Absolutely. Well, and leak detection especially seems like one of those things where hands-on learning would be beneficial.
Sure, absolutely.
I mean, it's like describing the concepts or the things that are happening might seem a bit obscure, or I don't know, is that true?
Well, I think many people, when they first hear leak detection, underestimate how challenging it can be. Mm-hmm. Just to say I'm looking for a leak, we probably grow up thinking about leaks is as simple as I think my inner tube on my bicycle has got a leak, so you spray it with some soapy water, and that sounds pretty simple. So now
right.
I've got a leak test, fuel injection assembly or whatever, air conditioning assembly, and initially they think about soapy water and bubbles, and it's
right.
much more challenging than that.
Oh, 100%. Let me ask you maybe something that's a bit of a silly question, but I'm curious. Does leak detection and vacuum, what is it, vacuum, does that always go hand in hand?
Well, for the leak detectors themselves, yes, because a modern leak detector, regardless of the manufacturer, has a mass spectrometer that's sensitive to helium, and they create a vacuum, actually a high vacuum, to be able to operate that mass spectrometer. So in that regard, yes, but leak detectors can also be applied for products and processes that have pressure applied to them. So, a wide variety of applications, actually.
Okay. Well, I pulled a quote from your website, and it says, "Many times over my career, I've arrived at a customer site and discovered the problem they're having is due to an installation of a leak detector or system with no advanced plans for proper venting of helium after the test is complete. Yes. Exhausting helium in the same room where testing is being done contributes to a high helium background that impedes successful leak testing." Why is this a problem?
Yeah. So when people hear helium leak detection, the first thing they're thinking of is a balloon.
Of course.
And we all have parties with balloons and helium, and you think helium rises because when you let go of the balloon or it gets away from you, it's gone, it goes up. When you're leak testing with helium, something I tell every class I teach, there's helium in the air we breathe. There's 5 parts per million in the air we breathe is helium. So when we release helium in the open air, you're now going to become a victim of the air currents of the room, the fresh air makeup. It's not just going to go up, it's going to go different directions. In fact, I have a video I've done where it shows one person spraying helium up, and another person has a helium sniffer towards the floor, and the leak detector reacts to it. Well, the only way that happens is that the helium went down to where the sniffer probe was at to detect it. So when I talk about exhausting, people still have that mindset that helium's going to go up. So I'm going to run the vent pipe and stop it just above my head because that's as far as I need to go because I think helium rises. Well, by the time you install your equipment like that and then you discover helium doesn't just rise, it goes different directions, it's very painful to address that because now the helium's floating around, and for example, you have a vacuum chamber, you put a product in, the door closes to do a complete total leak test of the product. When that door is open, if the ambient air is a high helium background, the door closes. Basically, I say it's taking a gulp of air that has a higher than normal helium background. Well, the leak detector is going to read helium that's from the room environment as well, and you potentially are going to have a rejected part. So typically what will happen is I'll get a call, somebody say, Dave, your leak detector's rejecting way too many parts. And I'll say, well, it sounds like you might have a helium background problem. And they don't believe me. I go to the facility, and it's as simple as getting a sniffer probe. And every modern leak detector, I don't care who manufactured it, you should be able to sniff normal helium, 5 parts per million, and get a baseline reading. And then when you have too much helium, because you're not venting it properly, you'll get a higher, and probably a very erratic behavior of the leak detector. So it's very simple to prove the concept. But usually, when I'm addressing this, it's too late. They're already experiencing pain and suffering. Production is really bad, and it has to be solved.
Yeah.
So my point is to all manufacturers, and also whether you're selling a leak detector or if you're using a leak detector, when you apply it, prepare for helium background concerns. Do it purposefully. Run your vent pipes out of the building so that when you vent a part after it's tested, you know the helium's going out of the area for testing. That's probably a very wordy response to what
I love it.
I have to ask. But if you've got time for a quick story.
Oh, 100%.
So my favorite helium background story of ever is I went to visit a customer who said, Dave, all 3 of our helium leak test systems are going crazy. And I go to visit them, and each of the 3 machines has 2 chambers. So a total of 6 parts can be tested at the same time. And the operator loads one chamber and then close the door, then you unload and load. All 6 chambers are very erratic. And so I go and I say, it looks like a helium background problem because there's no way all 6 of these chambers have the same physical problem with the leak detector. We get a helium sniffer probe out, and I'm playing a hot and cold game, and I find, helium's coming in from this fresh air duct over all 3 of the operators, same thing. I said, wow, where's this air coming from? And they said, it's coming from outside the plant. Really? We went up on the roof of the plant, and I can feel the wind coming across the building, and looking upwind, I see all these pipes coming out of the building. I said, what's that over there? And they said, that's the condenser department. And they have 12 vacuum chamber helium leak testers venting helium out through the roof. So it's going outside. The air current is bringing it across the roof, is being sucked in and blown over the top of these other. So that's my favorite of all time helium background story problem. But it sounds unbelievable, but we proved it.
Yeah.
So
I wasn't sure where you were going to go with that story when you said you went up to the roof.
Yeah, we went upside because I said, if we think this air is coming in, blowing over the machine, and I proved it had high helium content, where is it coming from?
Right.
So up there, and this is the longer story than I told you. I'm not going to go into greater detail, but the wind changes direction. So it doesn't always come from that direction to it. So they told me, said some days the problem goes away.
Interesting.
Then other days it's bad and we can never figure it out. So it was a fun one, really.
Yeah. Yeah. What are some other common problems that you see with leak detector systems and facilities?
So being a leak detector, I'm trying to leak test a product or a process. The leak detector can have its own leaks. It has a vacuum system. So the leak detector, you have to know, how does the leak detector normally operate, and what kind of signs can I look at to ensure it's working properly. But certainly issues with the leak detector can be a common problem that people run into. The helium venting we talked about, background, things like that. But then lastly, the seals, because you have to connect to a product so you can create an environment with helium to leak test that product. So these seals are very important, and there's companies that exhibit at the assembly show that do a great job providing fittings and seals to accommodate that. But as good as they do, eventually they get worn out. So a customer needs to learn how to not only monitor the condition leak detector, but the systems they're integrated with. And here we talk about at this show about also assembly automation and so forth. When an operator is going to leak test something manually, if they leak test and reject several parts in a row, they can think to themselves, maybe it's not the product. Maybe I've got a problem with my application, the leak detector system, and all that. But I probably maybe told you more than you cared to hear about.
No, I'm very interested.
But system
I
problems
think it's
with leaks, fittings, the ambient background problem, and the leak detector itself, they can all have a problem. So my training features how to teach somebody to evaluate all of those things for your success.
Are those some of the details, or what are some of the details people don't usually think about? a lot of things you've listed off already,
yeah,
right?
yeah,
I mean,
really.
like the source of helium. Now I know there's helium everywhere surrounding us right here.
Yep.
So, yeah.
Every
but,
breath,
yeah.
helium. You never knew it smelled so.
I had no idea. Oh, you learn something every day.
Yeah.
But yeah, what are some other details people don't usually think about?
Well, I don't want to get into optimizing or whatever, but many times people think about optimizing a leak detector, they think about fast. I want to test as fast as I can.
Mm-hmm.
But whether you're trying to test faster or do a very thorough job of leak testing, you also want to evaluate that the test is proper. You know, if I put helium into, say, an air conditioning compressor, I have to know that there's a compressing element to that compressor, and so when I put helium on one side, it may not get through to the other side of the compressing elements, the pistons or what have you, and I'm going to have enough helium on the opposite side of the compressor to do a good leak check. So that industry, we've learned that you need to evacuate and then backfill both sides with helium. If it's a complex part like a condenser, if I just put helium on top of air in a very fast cycle of a leak detector, I may have air coming out through the leak path with a leak detector that's only sensitive to helium, and I miss the leak. So optimizing for leak detection, beyond looking at how can I run the test faster, you also want to look to make sure you're applying helium appropriately for a given product so that you can reject the bad parts and not accept them. So that would be probably two major areas I would think about.
Okay, thank you. How do you determine the right method to test devices?
Very good question, because some people want to just do it the easiest way, and the easiest way may not be the best way or correct way. We, in our industry, recommend that you leak test a product the way it's used. So if it's a pressure device, then we want to pressurize it with helium, and ideally to the same pressure that the product operates in. So for example, an automotive condenser might be operating around 200 psig, so you might want to leak test it with 200 psig helium and a positive pressure. If it's a vacuum device, then we want to pull a vacuum and apply helium on the outside to duplicate the direction of test that you want for the product. If you test a part in an incorrect direction of test, you might miss a leak, especially with a product that flexes as you apply pressure or vacuum. I've seen it myself where a leak path might seal up in one way and then open up in the other pressure. So if it's a pressure device, but I pull vacuum on it, it might close off a leak that I care about, and I miss the leak, and now my customer gets a bad product. So,
Yeah.
That makes sense?
Yeah, well, sort of. If I'm being perfectly honest,
Yeah.
a lot of it is phew,
No.
but it's okay. It's a very niche area. I'm interested. I think it's fascinating, but there's a reason it's your specialty and not mine.
Yeah. I do have customers that say, Dave, we can't test it the way you're recommending. For instance, maybe the product, they want to have a person leak test the product on the workbench with a sniffer probe, and let's say that product really operates at 3,000 psig. Well, nobody's going to want to put a product on a workbench with somebody's face over top of it, 300 psig, because if it lets go, somebody might get injured.
Okay, yeah.
So they'd say, Dave,
that makes sense.
we're just going to put 50 psi on there. Well, they could miss the leak, and we talk about that. You can only do what you can do, but that might be a good candidate product for a robot to sniff it for safety's sake, so
Gotcha.
you can't boost the pressure.
This I am keeping up with 100%. Yeah, that makes a lot of sense. Safety issues, I understand completely.
Yes.
Yeah. So how do you optimize a leak detector system? What does that mean exactly?
Okay, optimizing is I want to test a product as quickly as I can without risking quality
Right.
and all that. So I am going to look at how long does it take to get, for instance, on a product that needs pressure applied to it, to pull a vacuum on it so that I put helium on there. Helium gets throughout the product as quickly as possible. So you look at the physics of it. How long does it take to pull a reasonable vacuum on it? How long does it take to put the appropriate pressure on that product? And then look at the leak test time to sense if there's leakage of that product and maybe measure it for the total leak rate. And then you also have to look at time to vent the helium and then pull a vacuum on the product before you backfill with atmosphere, and then let the operator have the part and stack it, put on conveyor, wherever it's going to go next. But you want to make sure you not only do that as quickly as you can, but don't risk quality. I have had a customer more than once call me and say, Dave, we got a product back from our customer, and they said it leaks, but it was passed on the system you sold us. And so we run the product again on their system, and we saw it pass again. They said, we know it leaks, but your machine's passing it. And I get to looking at it. Eventually, you do this. You're going to pull it back in the product and then put it in their test and leave it in the test mode longer than normal to see if the helium signature begins to develop to where it would be rejected. I have had more than one occasion where I showed the customer that for this product, you need to leak test it for about 4 more seconds to see that leak. Now, they're going to do one of two things with that, and I've had both sides of the coin been shared with me. One
The
was
smart thing would be to listen to your advice.
well, yeah, we'd say so, but they look at the given product and they say, all right, that's not a safety concern, and we think that happens 1 in a million, so we're going to still test it the same rate, and we know we're going to miss that one once in a while. I've had somebody who, it would be a health and safety thing, okay, we're going to have to test longer, means we're going to have to buy another leak detector so we still get the overall through-put that we need for that. So what causes that? Sometimes you have one product that the leak signature takes longer to develop than maybe the vast majority of the products. It has to do with the leak path. I don't know any of my customers, and I'm going to say none of my competitors' customers can make perfect little round hole leaks in their products. They almost always have what I would call a tortuous path. That's where the leak path is not just a little hole. It's, imagine if you will, an abrasement or welding, an entry point on a leak that kind of snakes away, I'll say, through the leak or through the abrasement and comes out another point. Well, it takes time to get helium through that leak path to be detected. The longer that leak path, the longer the time to detect it. So back to those two customers I was sharing with you, they didn't feel like that would happen that often. Most of the leaks was shorter leak paths, and just once in a great while they would get a really long one. So in one case they said, we're not changing anything. We know we're going to get a warranty claim on a part maybe once in a million. The other company said, we can't stand even one leaker because it might mean somebody's health and safety. So we are going to add more leak detectors and add more time. So it's something to think about when you're optimizing your leak test, not only for how fast, but to make sure that you can see the leaks you care about in the time allowed.
Yeah.
So
it's contextual.
One last thing about that is I tell people, I recommend strongly that they validate their testing. That means applying a known leak to a product, and you can buy them. You can get laser drilled orifices or permeation leak paths or leaks that can simulate a longer leak reaction, and put those in your product and see how long it takes to pull a vacuum, put the helium in there, detect the leak, and validate that you're doing a good job.
Yeah. So how can manufacturers monitor the wellness of a leak detector and keep it in good working condition? And actually, this is an interesting question because I hear people talk about utilizing AI for predictive maintenance. Does that factor into your industry at all?
It's on the radar screen. I'm not aware of anybody personally that's using AI yet, but I know people are looking at that, and certainly if it can help, we'll be all in on that. But wellness of your leak detector or the overall system it's integrated with, the manufacturers will have recommendations. But on the leak detector itself, they all have filaments that are the source of electrons that help the leak detector be sensitive, and there's status checks they can use with the filament. There's status checks they can use with a calibrated leak of helium that's a known value to see how the leak detector responds to it, predictably and in the response time expected. There's vacuum levels within the leak detector that can be monitored, but every manufacturer, and we have several of the manufacturers that show with Assembly Show South and also Assembly Show in Chicago, and they all do a good job of providing guidance on that. But the customers, the operators need to respect that, because if you don't, if the leak detector it does its job and nobody pays attention to it, it will come back to haunt you. There'll come a time when you're ready to run production and it's very clear now the leak detector is not working, and it can be a lot of weeping and gnashing of teeth to react to it when it's really too late. I mean, you can fix them, but now production's waiting for you to do that. Now, people will say, well, we'll have a spare leak detector. So when you have that, we'll put the spare on there. I'm not going to say who it was, but I've had more than one customer. One in particular had 10 spare leak detectors, and in my field service days, I would get a call at some point in time, Dave, we need your help. Go in there, and all 10 leak detectors down. So that meant that every time they swap one out, the bad one goes over against the wall, nobody pays attention to it.
Right.
Next thing you know, they got 10. So if you got spare leak detectors, and when the bad one comes offline, that's your opportunity to get it serviced so it's ready for the next time you need it. So.
Well, Dave, I certainly appreciate you sharing your expertise on the podcast. What's on the horizon for leak detecting generally and for you with your business?
On the horizon for leak detection, people have been trying to get something better than a helium mass spectrometer since before I started my career way back in 1989. So far, helium is an inert gas, smallest molecule for the vast majority of applications for manufacturing. Still seems to be the best way to leak test. Some people are replacing helium with hydrogen for sniffing applications with the same leak detectors that detect helium, and they can do that. But for the short horizon view, I think helium leak detectors are here for quite a number of years. So really the opportunities is how to just optimize systems and make them more reliable. And they're doing that. When I started my career, you could depend on a leak detector needs to be overhauled every year, most often. And now the major manufacturers, the leak detectors can go many years without doing anything but maybe changing vacuum pump oil, and much more resilient. So doing that. For me, myself, I started Tracer Gas Technologies in October of last year. And I did so because I was deciding between retirement or I think I'm young enough and enjoy training and consulting. I'm going to give it a go. And it's the two most enjoyable things that I've done in my career is the training and consulting to help people out. When I was in sales, I said if you help people when they need help, business takes care of itself. You really don't even have to sell. You just help them. They'll come to you for when they need product if you'll help them.
Makes sense.
So on my horizon, I've done a few really enjoyable training events already. I went to a Canadian National Lab up in Saskatchewan. I went out to Tinker Air Force Base a few weeks ago, provided training there. Got a few more things on the horizon. So I'm on an upward trajectory. I don't know that I'll be as busy as I was in my previous career, but I have a lot to look forward to, and I enjoy it immensely. I've met so many good people thanks to leak detection throughout the world, really. So it's been a fun career.
Yeah. Well, Dave, thank you so much for joining the podcast. I really appreciate your time today.
Thanks for having me. I enjoyed it.
Absolutely. Thank you for tuning in to this episode of Assembly Audible. Until next time, I'm Jennifer Pierce signing off for today. Thanks for listening. Bye.